right, so we're moving along here to 4.2. We may spend a couple days on this depending on how you guys do, but we're going to be able to graph rational functions and look at a rational expression, a rational function, and I want you to be able to graph rational functions after this. So we're going to take a look at a few of the problems we talked about yesterday, but didn't really do any graphing um, with these types of problems. So first of all, we're going to be able to take this problem right here and rewrite it in the form y equals a over x minus h plus k. Okay. And again, I could put the k in front. It doesn't matter. But there's some very, very, very important things we need to look at here. K is going to be my horizontal asymptote. Okay. And it's always going to be the equation y equals. H is always my vertical asymptote. Okay, and that's going to be x equals, that will always be the opposite of whatever is in the denominator. So whatever this value is, if that said -3, then this would be x equals 3. So if we look at this problem right here, if I ask for the vertical asymptote, it would be what value makes this equal to 0, and that would be x equals 3. If I ask for the horizontal asymptote, I would have y equals 4. So you're going to have to be able to graph these and understand that every time you're going to have a vertical asymptote and you're going to have a horizontal asymptote. And then we're going to put branches on this graph depending on what the graph looks like in Desmos. Okay, so let's do an example of this. We're going to use long division here, okay, to do this. So in order, that's what this slide is kind of showing. If you ignore my writing and look at this, we're going to use long division. You also could use synthetic division if that works for you, but we're going to use long division to get this equation right here, okay? So looking at this equation, I'm going to put the 6x on the outside, put the 2x plus 1. Nope, I got that backwards. 6x divided by, yes. Sorry, got it backwards. What am I doing here? Come on, get it together. There we go. Okay, so again, whatever's on the denominator goes on the outside. Whatever's in the numerator goes on the inside. So I've got 6x, sorry about that, 6x divided by a 2x plus 1. So what can I multiply by 2x to get a 6x? And the answer to that is 3. 3 times 2x is 6x. 3 times 1 is a minus 1. So I'm sorry, is a minus, there's a plus 3. Goodness gracious. 3 times 1 is 3. So I subtract, I change both of these signs. That cancels, that gives me a -3. So I am left with a 3 plus -3 all over 2x plus 1. So for this problem right here, what is my k? K is 3. So my horizontal asymptote would be y equals 3. My vertical asymptote is what value makes the denominator equal to 0. So I would take 2x plus 1, set it equal to 0. 2x equals -1 divided by 2, and I get x equals -1/2. Okay, so my vertical asymptote would be -1/2. So again, if I jump to Desmos here and I graph that function, what was that? 6x over 2x plus 1. So 6x over 2x plus 1. You can see that I have the graph right here with a vertical asymptote of -1/2 and a horizontal asymptote right in here at what we said was 3. Okay. So that's how you need to graph these. You're going to have to do long division. Get back. Remember that from when we did it last chapter. Okay. Okay, so this is just explaining what a rational function is. It's just as a rational number is the number that can be expressed as the ratio of two integers. A rational expression is an expression that can be expressed as the ratio of two polynomials. So I have a polynomial on top divided by a polynomial on bottom. When I actually have a rational function, it's going to be set equal to something. Okay, so we're going to deal with more rational functions next class. Right now, we're going to be dealing with rational expressions to be able to graph those. Okay. So, how do you find vertical and horizontal asymptotes? So, the first thing we're going to talk about is vertical asymptotes. To find a vertical asymptote, we are going to set the denominator equal to 0. Okay. Vertical asymptote, we're going to set the denominator equal to 0. The denominator equal to 0 and factor. Okay. So I'm going to set the denominator equal to 0. I've got x. I'm going to, what two numbers multiply to 12 to equal 7? That would be plus 4, x plus 3, right? And then I use the zero product property. So then I solve for x. So I get a negative 4 and a negative 3. This problem right here would have vertical asymptotes at x equals 4 and x equals negative 3. Okay. So these are my vertical asymptotes just by setting the denominator equal to 0, factoring, and solving. Okay. So these graphs are going to get really, really, really funky the way they look. That's why we're going to use Desmos for a lot of this. Now, horizontal asymptotes, we have to pay attention to the three separate cases. Okay. So looking at the problem, we're looking at the degree of the numerator versus the degree of the denominator. What is the degree? It's the largest exponents that is there. So in this problem, this is a visual thing that we need to be able to look at. What's the degree of the top? The degree of the top in this example is 1. The degree of the bottom is 2. So there's three cases we look at. Case 1, the degree of the numerator is less than the degree of the denominator. If that happens, that is automatically y equals 0. Okay. Case 2, if the degree of the numerator is greater than the degree of the denominator. So all we're doing is looking at these two numbers. Is 1 less than 2? Yes, that would be case 1. Is 1 greater than 2? No. So it's not this case. But if that happens, the degree of the numerator is greater than the degree of the denominator. There are no horizontal asymptotes. And then the last case is if the degrees are the same, we divide the leading coefficients. Okay, so we're going to look at 3 different examples of this. In this one right here, I would have a horizontal asymptote at y equals 0. So if I went ahead and graphed this problem, we just found the two things that I needed to find. Okay. If I went ahead and graphed that problem as y equals, and I put x minus 2 on top, 3x, goodness gracious, minus 2, okay, and understand I'm going to divide the whole thing. Notice how I highlighted that to get that whole thing on the top. And then on the bottom, I put x squared plus 7x plus 12, x squared plus 7x plus 12. It's going to give me this really weird looking graph, right? Okay. Now, what did we say? This had vertical asymptotes, right? We said this thing had vertical asymptotes at what two values? We said it had vertical asymptote -4 and -3. Okay, so if you look at -4 on my graph, there's nothing here. And at -3, nothing here. Okay, so when you are looking at those and graphing, we would have drawn those lines there. And then at y equals 0, there's no asymptote. So again, using Desmos and graphing this at y equals 0. I know it it crosses right here, but again, it gets really close and comes back down to this. So these graphs look really strange as we're doing this. The algebra is how we find the vertical and the horizontal asymptote. So I want to look at a few examples like this. Okay, what is the graph of this function? So in these graphs, the first thing that you're going to be asked is what is the vertical asymptote? So we have to find the vertical asymptote. How do we find the vertical asymptote? We're going to set 3x minus 4 equal to 0. Okay, I'm going to add 4. 3x equals 4. I'm going to divide by 3, and I get x is equal to 4 over 3. So if I were drawing a graph, I would go over to 4/3, which is right here, and I would draw a vertical asymptote. Okay, Then it's going to ask you to find the horizontal asymptote. What do we have to do? We have to compare the 2 degrees. What's the degree of the top here? Even they don't see it, this is degree 1. This is degree 1. When they are the same, what do? When the degrees are the same, we divide the leading coefficients. So we're going to divide the leading coefficients. It's not tough math, okay? Not tough math. I get y is equal to 2 over 3. So at 2 over 3, which would be about right here, is my 2 asymptotes. Now, it's going to ask you to graph this. So we would go over to um, Desmos, and you have to, it's a multiple choice, so you have to just look at where the branches are. Okay, so that's a 2x plus 1 over 3x minus 4. So when we graph this on Desmos, we've got a 2x plus 1 divided by a 3x minus 4. You should be able, you can't see, they don't show the asymptotes, but this is right where they were. And then they have the branches down here on the left. I kind of say the quadrants, right? This is quadrant 1, 2, 3, and 4. Branches in quadrant 1 and quadrant 3. Okay, so when you graph this or when you give the multiple choice to go look at this, we know that the graph will be in here, like this, and like this. Okay, again, not going to cross that asymptote right there. Okay, let's look at one more example in graphing these. So again, first thing we've got to do is find the vertical asymptote. So we're going to set the denominator equal to 0 and solve it. Okay, so I'm going to factor this. What are 2 numbers that multiply to negative 15 and add to 2? That would be a plus 5 minus 3. So I've got x equals negative 5 and x equals positive 3. So there's going to be my vertical asymptotes at negative 5 and at 3. Okay. Now, some different things could happen in the middle here. But now let's go ahead and find my horizontal asymptotes. What's the degree of the top? Degree of the top is 2. Degree of the bottom is 2. Right? So degree of the top is 2, degree of the bottom is 2. So how do I find the horizontal asymptote? I'm going to divide the leading coefficients. So I'm going to divide this 4 over 1. I get y equals 4. So again, up here, and again, you got to make sure you know what I'm talking about when I say degree, when I say leading coefficient, right? There's no, you don't see it here, but there's a 1 there. So if I go and put this into Desmos, okay, take a look at what it looks like. 4x squared minus 9 over x squared plus 2x minus 15. And I put this into Desmos. I've got a 4x squared minus 9. Divide that whole thing by x squared plus 2x minus 15. Okay, so look, it gives me this little like parabola shaped graph down here. And then up here, I've got the 2 branches. Okay, so if I go back to that graph and draw a rough sketch of that, I've got the little parabola that goes down in here, right? And then I've got the 2 branches out here. So you would have to be able to look at the multiple choice graphs and find that. If it asks for a y-intercept, it's whatever this value is. Like if it goes back and asks you for a y-intercept, well, this is where it crosses the y-axis, right? If it asks for x-intercepts, there's my x-intercepts. Now notice we have 3 different shapes of this graph. These graphs all look different. There's no way for me to say this graph is going to look this way. You need to put it into Desmos and take a look at it. Okay, so we're going to do some graphing. This kind of summarizes everything. If you ever get confused, you can go back to this slide right here and take a look at it. So good luck with this assignment. I think there's 16 questions. Make sure if you have questions, you're logging on to that Google Meet and you're asking me.